This is the final video on the two-stage oscillator that my grandson and I have been working on. Had to do quite a few changes on it to get it to work the way we wanted, and it's kind of working now. You can see a lot of the changes I made here on the generator portion. I've got 6 coils and 7 sets of magnets on the generator. One of the problems we had was getting enough speed of the magnets past the coils to get the voltage that we wanted to be able to charge a battery. And it bounces up and down pretty good, so I had to put weights on it on the front and the back. I've got several batteries hooked up so I can show you how it works, and we can also look at the traces on the oscilloscope. I've got a FET that is triggering the power coil. We've got 3 windings on the power coil, all in parallel, triggered by a FET, and I'm using a Hall device sensor. Don't know if you can see that or not in the picture. It's just below the magnet there on the bottom of the coil. So it just triggers once per revolution, which is what we wanted. The trigger winding we're not using anymore to trigger the circuit. We are using it as a Jenny coil and running it through a full wave bridge rectifier, which feeds right back to the run battery. Then in addition, we're capturing the spikes off of the power coils when they discharge and running them through a diode and a capacitor, regular SSG type circuit, and we're running it back down into the charge battery. On the controls, I've got a off-on switch, and it has 2 positions. In that position it runs and bypasses the ammeter. In that position it goes through the ammeter so I can check the current draw. We've got another switch down here that lets us select which battery is on charge and which battery is running the machine. So the toggle position indicates which battery is the run battery, and then the other one is the one being charged. So right now that's the battery it's going to be running on, and that's the charge battery. And then we're catching the AC off of the back, running it through a couple of diodes and a couple of capacitors in a double voltage doubling scheme, and we're running it out here to charge battery. So I can show you what all the voltages are here to start with. This one is setting at 13.19. This one is setting at 13.07. This is setting at 13.12. This is the one it'll be running off of to start with. So I'll turn it on and we'll get started running. You can see the waveforms there. Getting pretty much full swing on it now. If I unhook this battery, then you can see the voltage is climbing up pretty good. So I got plenty of voltage available to charge that battery with. If you look at the scope shots you look at the amplitude on that channel 2, it's up around anywhere from 250 to 300 volts peak to peak. Of course, when it goes through the capacitor, when it's stored on the capacitor, it's not that high voltage. I'll expand this out. You can see the waveforms across the FET. And I'm getting fired once per revolution on the wheel. If you can see the frequency there, zero in on that. It's running around 85 to 92, somewhere in that range. It varies. There's 100. So that's the frequency that the wheels turn. And of course, on the output, the frequency is a lot slower. But it actually goes up and down each time that the wheel goes around. So it's, if you figure there's 14 magnets on the wheel, so the arm's going up and down 1/14 of the speed of the wheel going around. Okay, that's showing 32, a little over 32 volts now across the capacitor. So I'll hook the charge battery up. See it climbing a little bit. Now it'll also carry about 100 milliamp load, so I've got a strip here I can put on. About 100 milliamp strip. And that'll pull the voltage down some, but it'll stabilize somewhere around 12.8, somewhere in that range. And the battery that's getting the kickback charge is climbing up. One battery setting at 1252. You can check the amp draw. It's just under an amp, probably about 900 milliamps, something like that. I usually don't leave the ammeter on. It runs better without it. Now this one's up to 1384. This one's dropped back to 1306, carrying 100 milliamp load. And there's the waveform. We're getting pretty much full swing on the Jenny coils. This mechanical oscillator really works a lot better as a mechanical device than as an electrical device. It's just hard to get the speed that we need on the back end, on the work end, to generate the kind of voltage that we want and the kind of power that we want. When we were running with the pendulum and just checking the mechanical output of it, it looked pretty promising. Like if you were going to pump water or something with it, I think that's really probably the best use for this type of device. But we were kind of determined to try to get this thing to put out some electricity, so that's where we're at. Okay, it's dropped down to 1298, 1299 with that load. We're up to 1393 on the charge battery. Swap batteries, just flip that switch. Now this becomes the run battery. You can see it dropping, and this one is charging. That's kind of the normal SSG function. Doing a double recovery. Got a full weight bridge rectifier on the one small coil, direct back to the run battery, and then we're collecting the spikes when the coils collapse to charge the other battery with. We got both radiant charging and a more conventional charge. Anyway, I think I'm done with this. I think I got to the point I'm just going to ship it off to my grandson and let him play with it. Thanks for watching.